Hello and welcome. So in this video tutorial, we will try to understand what and how deep sorting tracking algorithm works and when compared to other techniques of tracking. Later, we will also be implementing a complete project using the YOLOV4 and deep sort algorithm. So sit back, relax, and do not forget to like, share, and subscribe to the video. So let's start. Now let's try to understand what object tracking is and how it works. Now we cannot just use object detection for tracking because object detection works only for one frame, right? We cannot keep track of objects in sequential frames. Now in any sort of occlusion, you will lose detection and your target may slip out of the frame. So object detection works great for one single frames, but we cannot totally depend on object detection for object tracking. In order to track an object in a proper way, there are many computer vision techniques like optical flow, mean shift, Kalman filter, etc. I will try to make you understand about these algorithms in brief. First comes the mean shift algorithm. So it works by taking our object of interest, which you can visualize as this ball in front of you. Then we go to the next frame and we search in a larger ROI, that is region of interest, known as the neighborhood for the same object. That is our ball. Okay, initially it was here, so obviously with some velocity it comes here, so we try to search in the nearest neighborhood in order to find the position of the ball. Now we will want to find the best region of pixels in the next frame that best represents our ball by maximizing the similarity function. Now obviously if you're in your home quarantined and your phone goes missing, you won't go to the police station immediately, right? First you will search near you, that is in your home or in your neighborhood. So this is how the mean shift algorithm works. So it initially starts from this position of the model in the current frame, and then in the next step it searches its neighborhood in the next frame. Okay, so next come to the optical flow algorithm. So it looks at the motion of the features due to the relative motion across frames between the scene and camera. For example, let's say again we have this car in the frame and it moves down bottom right towards bottom right in the image. You will be able to estimate the motion vectors in frame 2 relative to frame 1. That is frame 1, let's suppose in frame 1 we have x1 and y1 coordinates, and in frame 2 it comes here, okay, and with the coordinates x2 and y2. That is, this car is moving with a certain velocity, right? We will be able to use these motion vectors to track and even predict the trajectory of the object in the next frame. So it basically calculates the relative motion of detected objects across frames between the scene and camera. So next let's talk about the pros and cons of mean shift and optical flow algorithms. So pros are obviously good tracking performance as we are searching in the nearest neighborhood of the frames, but we have some cons, right? It is computationally expensive and it is really prone to noise. And due to the noise and also due to the occlusion, it may track its lost, okay? Because if the object moves too fast, you will lose the track. So these are the pros and cons of these two algorithms. Now there's a better algorithm than these two, which is known as the Kalman filter algorithm. So it works by assuming a constant velocity model and Gaussian distribution. We can guesstimate where the car is of its motion. If it hides us, it can detect it. Now there is so much more to the Kalman filter and I cannot explain it in this. I will provide some materials in order to understand more about the Kalman filter. Now let's finally come to Deepsort, which itself uses a Kalman filter inside it. Now sometimes a Kalman filter may not be to track objects in a noisy video or images. Here enters SORT, which is short for Simple Online Real-Time Tracking. So SORT comprises of 4 main components that are number 1 detection, number 2 estimation, number 3 association, and number 4 identity creation and destruction. Now next comes to the Deepsort, which is an upgrade to the sort algorithm. So Sorry for the blur image, as a high dimension image was not available to me, so I rather use this. So WellSort achieves an overall good performance in terms of tracking precision and accuracy. Also, despite the effectiveness of Kalman filter, it returns a relatively high number of ID switches, which has a deficiency in tracking through occlusions and different viewpoints. So, in order to improve this, the authors of Deepsort introduced another distance metric based on the appearance of the object, that is, the appearance feature vector. It basically extracts meaningful features of the objects that needs to be classified and detected, and we remove the output layer, the dense features which are ready to be classified. So as I said, this is of appearance feature vector. So in this, we remove the classification layer from here, and we keep the two convolution modules, and we use the max pool output layer. Okay, so that is what appearance feature vector does. Now, how this works is that after the appearance feature vector is obtained, they use the nearest neighbor queries in the visual appearance, and this is to calculate the measurement to track association, that is MTA. It is a process of determining the relation between a measurement and an existing track, and after that, the sort algorithm is applied, which we learned 2-3 minutes ago. So this is what deep sort is and how it works. Now let's finally get to the implementation of the deep sort with YOLOV4 model. So here I have prepared my repository to implement the YOLOV4 deep sort algorithm. So just go to the code and copy this link. Okay. So then go to any folder and clone it. Okay. So I have already cloned it using the git bash window. So after cloning the repository, you will get something like this. Okay. So after that, download the weights, as I have already downloaded the weights in the data folder, as you can see. And here for this tutorial, I am using YOLOV4 tiny weights. Okay, you can also use the large weights. Okay, you can go to the official website of the YOLOV4 and download it from there. So in this, I will be using YOLOV4 weights, the tiny version. So now we need to convert the darknet weights to the TensorFlow weights. For that, just run the same model. Okay, so same model py file. So after running the py file, you will get something like this in the model directory: variables, kras metadata.pb and save model.pb. So I have already done it using this file, save_model.py. So you can clone it using the link I have provided in the description. Okay, so just clone it and run it. Now the next step is to run the object tracker. Okay, this is the main file, right? Now before that, you need to create a conda environment, right? Anaconda environment. I recommend using Anaconda instead of pip. Okay, so just go to your terminal and go over to the YOLOV4 directory, and in there run conda env create -f and name the file conda CPU or GPU if you have a GPU CUDA enabled system. So after running that, you will create an environment and just to activate my environment. Okay, so let's just do that. Conda activate YOLOV4 CPU. So that will activate my conda environment, the environment which I created using the conda-cpu.yml file. Okay, so I'll just explain what I did. So first step is to clone my repository. Okay, and the next step is to run the object tracker. Now I've already converted the net model to TensorFlow model, right? Here, this is the darknet model, YOLOV4 tiny weights. Okay, now I converted this to TensorFlow model using this file. Okay, save model file. You can skip that, or you can experiment it yourself using the YOLOV4 large weights. Okay, so the next step after converting the weights is to run the object tracker.py. Okay, so now let's run the script python object tracker. So as you can see, the FPS is low, but as I am running on CPU, so FPS will be low, but it is quite good. Okay, it is detecting and it is tracking, and it is also allotting the IDs to each and every person we can see in the frame. So it is pretty great. Okay, Now we can see the FPS also. It's approximately say 7 to 8 FPS, right? But that's also too cool, right? You can use GPU and further it can boost the FPS up to let's say 15 to 20 plus FPS. Cool. And also you can also change the video part to 0 if you want to do detections and tracking on your webcam. Okay, just do it to 0, just change it to 0. Okay, but for right now I'm doing a test. So, and next, if you want to change the classes, right, like if you don't want to detect all and track all the objects and you want some specific objects, right, to track, so you can do one thing is so this is right in coco.names. So these are all the classes you have. If you go in data and classes, coco.names, okay, this consists of all the classes that it can detect. So these are all the 80 classes, okay, that it can detect. So if you want to detect and track all the classes, just uncomment this statement. Otherwise, write your own classes that is mentioned in the coco.file, okay. And for right now, I have used only person and car classes to detect and track. So yeah, this was all for this tutorial, and I hope you liked it. So please